Hi guys, today I'm going to show you guys how to implement uniform circular motion with C++ using the Allegro library. Now before I start with the code, there are a few things you need to know about uniform circular motion. The first thing is that the speed is constant, but the velocity is not. The velocity has direction, so the direction changes, but the magnitude of the velocity does not. Also, because the speed is constant, there is no tangential acceleration. However, there is a centripetal acceleration, which is what is causing the particle or the ball to move in a uniform circular motion. And that's the basic stuff you really need to know about uniform circular motion. So to start, I have declared three floats, x and y. These are going to hold the position of the object that is going to go in uniform circular motion. And I have velocity, that's the velocity of the object. I have a float called alpha. Alpha will be the angular velocity. The angular velocity is how fast the angle is changing. And I have theta, which is the angle, and then I have the two components of the velocity, velocity x and velocity y. And then I have the change in time. Right here, those are all typical lines you would put in pretty much any allegro program. The while loop is where the real code starts. Now I have theta equals theta plus alpha, so I'm gonna increment theta by the angular velocity, because angular velocity is how fast theta is changing. And then I have velocity x equals velocity times cosine theta, and velocity y equals velocity times sine theta. I also have x equals x plus velocity times change in time. This comes from one of the kinematic formulas, which states that final position equals initial position plus initial velocity times change in time plus 1/2 acceleration times change in time squared. Now the acceleration is 0, so this portion of the formula is 0, so we end up with this portion, which is the portion that I have in my code right here. And it's the same thing for the y, and all I have to do now is create a circle with position x, y, radius 4, some color, and then I draw it to the buffer. Notice that I don't have a variable called centripetal acceleration. This is because by consistently changing theta, I am accounting for the effect of centripetal acceleration, so I don't really need it. And that's pretty much it. This is how it looks if I run it. And voila, uniform circular motion. Alright, if you have any question, just comment below asking me, and I'll see what I can do.